Okay, I guess we can start. Hi, I'm Łukasz. I'm your host today. On the back, okay. I'm your host today. Welcome to our first meetup in 2024. I realized that we've been running this show for 9 years now. That's the photo from the first one. Some of you were there, I can see that. Thank you for all the support over the years, like speaking, attending, kind words, stuff like that. We are not planning to stop, but we're looking for some help. I'm happy to accept some volunteer help with coordination, event facilitation, looking for venues, preparing the venues before, looking for speakers, marketing, basically everything. This way it will be easier to run it every month as I plan to, but it's not working every month. Also, like speakers, if you like to speak about something for beginners, that's fine. If you have something to say that is crazy, that's okay. I know that some of you are afraid of speaking in front of camera. We can do off-camera talks as well. That's not a problem. And of course, we're looking for sponsors, either sponsoring venue or food, beverages, whatever. You can contact me everywhere. I'm everywhere I can be. That's the Slack that we use. By the way, if you are not on Slack, I suggest you join. It's a very cool place to ask about Scala, talk about Scala, or basically about everything in life. So what's coming next? Next month there is Scala conference in Warsaw. We got some discount for workshops and for tickets, so if you would like to join us, that's cool. If not, you should join our epic pre-party as every year. It's gonna be at Uwaga Piwo, the same place last year. You can see a photo over there. Please RSVP because we need to know how many people are going to join us. It's open to everybody. If you're not coming to Scala, that's fine. Just come and say hi, grab a beer, and something like that. So today, agenda for today, first it's meet and greet, so it's now. Then it's Tomasz. After that, there is a break. You should buy some drinks. There are coupons on my table. We should use them all, of course. And then there is a talk by Łukasz. Łukasz is not here yet, but I will join. I know he's in Warsaw, so maybe the protests stop him or something. I don't know. And then we can stay here and just have fun until you want to go home. I usually don't stick to schedule, sorry about that, especially to those on live stream. We are just very spontaneous, I guess, or disorganized. A few last things, if you want to tweet, we are at Twitter or X now, okay? I hope this even is live streamed. If not, it's recorded. The recordings will be up tomorrow. This meetup is sponsored by Iterators, so the venue and the drinks. Yeah, and the coupons, I already mentioned that. So, feedback will be at the end. That's also something new. I will get to that. So without further ado, Tomasz.
Okay, let's start. It's visible, the pointer?
Yes.
Good, good, okay. So, welcome everyone here on Place and people on the stream, if there are any. I hope there are some. So, welcome to my presentation titled Not Your Grandpa's Java. So, we'll be comparing the syntax features of Java 28 and what's coming in the next Java iterations to Scala 2. Why not Scala 3? Well, because I think Scala 3 ran away far away into the future, so that comparison would make a lot of sense. So why this presentation at all? So Java architects were making a lot of changes in the past decade to Java, and I wanted to show you how Java slowly approaches what we know as Scala 2 at this point. And we're going to only focus on syntax changes. So we won't be talking about performance changes or, for example, Loom, virtual threads, I don't know, some APIs, or for example, I don't know, some kind of Panama project which wants to gap the, create a bridge between the native code and JVM. So that's not, this presentation is not about this. Okay, so a super short slide about me. So my name is Tomasz Kogut. I'm working currently as an engineering manager and tech lead in an adtech company. I've been doing Scala since 2010, around 2010 I think I started, and like my work mostly focuses on data and AI. So I'm not working like creating APIs and stuff. I'm mostly working on making data products. If you want to catch me, there's my Twitter handle, which is I think a bit cut, but like you can just ask me later on, so not a problem. Okay, so that's enough about me. Let's talk about Java. So what kind of Java we're going to move? So I've called this like your grandpa, your boomer Java. So like what kind of Java was written in 2005, maybe earlier? So which version of Java are we talking about? So it's like 8 and before 8 Java. I mean, Java 8 brought some kind of nice features like streams, but those are, I think, like popular enough that we won't be focusing on them. So Java 7, 6, 5, when generics approached. And I don't know if you know that before Java 5, Java was actually called 1.4, 1.3, and names like that. So this is like the baseline that we're going to see how like this changed over the years. So what is the boomer's Java, the original Java way, how it was like designed? So in Java, like from the past, like 2 decades ago, everything has to be an object, even if it probably shouldn't be. So like Java was like designed as a hyper object-oriented language. So like people had this idea, so we have real business problems, we're going to map it to like some kind of programming concepts. So that was the idea of Java developers. So kingdom of nouns. There's like a super cool, blog post by a guy named Steve Yegi. Okay, this is again cut. So this blog post is from 2006. You just need to like search for kingdom of nouns Java and you will find this. Really worth reading. So like this is like a satire on how the Java programmers like programmed like let's say 2 decades ago. So there's like an example how would you actually model taking out the trash. So basically like in Java you cannot have functions. I mean like those 2 decades ago the boomer Java didn't have functions. Everything had to be an object. So like how would you model taking out the garbage? So basically of course you need some kind of classes which will be like objects. So you need garbage repository manager. Basically, you need to put the garbage somewhere, right? There would be like a class called trash disposal plan executor because you need to plan how to take out the garbage. Garbage disposal destination locator because like obviously you need to find a way to the garbage bin. Garbage disposal strategy because probably there's a business requirement that you need to now sort things like glass goes to one bin, plastic to another one, right? And trash disposed callback object because you need to somehow get back from the trash back to your home and sit on the couch. So because we didn't have any functions at that time, so basically you would compose all those objects and there would be like a method called doIt because like the names should like tell you what is actually done. And this is like contrary to what like other languages at that time would probably just have like a single function called take out the trash and that would work as well. So in that Java, verbs as like functions cannot exist. Only nouns could exist. So in that Java, functions were actually objects, and that made a very funny kind of APIs that Java developers had to design. I'm not sure if you are able to see the code, but I will try to at least explain if it's like the font is too small. Didn't anticipate that. So this is an example of like a framework called Swing. Maybe you've heard about this. Like Swing is known, like it was intended for building desktop applications. It was best known for looking as trashy on each of the systems it was run. But it was like you could run this program both on macOS, Linux, and Windows. So that was the nice thing. I think if you use NetBeans, it uses Swing. So here's like an example code. So we have a button, of course, called JButton. So it has a label, click me. And now what you want to do, of course, you want to click on the button, right? So because, like, what you would expect, that you could somehow attach a function to a button, right? And you'll click and that function will be invoked. But like that, this was not the Java way. The Java way was to create some kind of object. So we had a mouse listener interface that you would put to mouse listener method. But because this was an interface, and you can not only click on a button, you can also, this is like mouse clicked, you can also press it, release it, enter the mouse, the mouse can enter the button or exit the button. So you would need to like fill in all of those functions, right? So that was very not super helpful. Like it would generate like lots of code. I mean, if you are paid per line of code, maybe this is good, right? But I don't think anyone does it now. So the Java developers had to somehow overcome this problem. So there would be something called a mouse adapter, which was like not an interface. It was probably, I think, an abstract class, I think, that implemented the mouse listener. So you would only override the methods that you actually needed, and all of them other were just empty. So this is how people like design APIs at that time. So if you compare it to something like React, right? React is like very common for building rich applications, even desktop applications now. So if you have a button, the button has a property on click, which basically you can attach a callback function, and that's it, right? So like everyone moved from this kind of paradigm. Deep inheritance hierarchies. So also the idea of like inheritance also was very like popular in Java. So how would you design stuff? So you would have an interface, some kind of base interface that could perform for service. And like obviously you always had to have some kind of interface on top. That was like a golden rule. If you create a class, you should probably have an interface on top. That was also a rule from that years. And you would have like base service implementation. So this is like a concrete implementation that you can actually call. Then if you had to specialize, you would inherit from the base service implementation and add your stuff. Then you could specialize it further and specialize it further and go down the inheritance chain. So basically, this was really fragile. Like imagine, I know like Scala people like to, for example, control side effects, right? Now let's say that you think that you're talking to a base service and you don't know if the service is talking to a database or maybe it's talking over gRPC or whatever, right? So it was like super, super fragile. And also this was intended to have some kind of strong encapsulation, but as I said, it always leaked out. You always had some kind of details that you didn't want to see. For example, you thought that you're working with some kind of service, and then you saw like JDBC exception or gRPC exception. Probably gRPC was not a thing but like that's how it was done. Okay, now how we changed, like now everyone says that favor composition over inheritance, right? And why all of this was like that, like 20, 25 years ago? So how many of you created an UML diagram in the past, I don't know, 1 year, maybe? 2 years? 5? Oh.
I study, so like that doesn't count.
It doesn't count. Academia is always like 20 years behind, unless it's Oderski who is doing the research. He's like 20 years in the future. So, so basically, but you know what is UML, right? Probably everyone knows. So this was like a unified modeling language. So there was this idea that there will be some kind of super intelligent, hyper intelligent people called architects. That's probably why we still hate architects to this day. So they would design the program in a like with this graphical interface, preferably in some kind of IBM tooling, which you would have to buy a license for like many thousands of dollars. And there would be some kind of like cheap labor, probably overseas, that would fill in the gaps. So only write some kind of like stupid code. But the whole framework, the whole architecture of the program would be somehow like made by those super architects. You know why? Why this was so popular at that time? You know what is the biggest risk for all software like initiatives? Always? Programmers. Because programmers are super expensive, like they like to like hop jobs. So every time like in each generation. So like business wants to somehow get rid of us. I don't know if you're following the AI hype right now, the LLMs, the ChatGPT and stuff. Have you heard maybe that you don't need to learn programming now?
NVIDIA claims that children shouldn't learn programming anymore.
Yeah, and like the CEO of NVIDIA said, don't learn programming, you'll be using English, right? So the idea is that, AI will replace programmers, right? So I don't know, I think people who, this is very similar to this, I would say, right? So I think that people who don't know history are doomed to repeat it, but we'll see. Okay, so this was like a introduction to what Java was. And now we're going to talk about like Java 21. So we have like year 2024. Java 21 is on the stage, and we're talking about all the nice additions in this range, right? So this is Gen Z Java, let's say. Okay. So after this very pronged introduction, let's get into the agenda of the talk. So we'll try to tackle the problem from two sides. So you maybe heard about this book from Nicholas Wirth, Programs Are Data Structures and Algorithms. This is like a classic from, I think, 70s. So I will try to show how Java changed over the years with all additions, and how it changed how we model data structures and how we model algorithms now in Java, and how this somehow relates to what we do in Scala already for the past decade or something. Okay, so let's start with data modeling. Okay, so the best way to start programming is actually to design some of your data structures, I would say. So, like, your grandpa loved to make everything objects. So even if something didn't need to be an object, then for sure in Java, 6, it was an object. So let's have a simple example here. So we have a class person, which has a list of orders, and there's, of course, a class orders, right? And probably how would you model this in Scala and other languages? This would be like pure data, right? Probably without some kind of identity. I mean, like identity in the sense that you can, for example, serialize this or do something interesting with this. But in Java, it was a bit different, right? So, for example, I don't know if any of you use OREMs, for example, like Hibernate or something. So in Java, how this would work, so because this is like an example from that you're trying to read this data from SQL database like Postgres, right? So you're doing a join between a person and his orders, right? Then you have like rows, and you have a problem, right? That each row has repeated data of the person, and you have all the details of each order, right? Then you need to somehow map it back to the object. So this is called, the problem of mapping this back is called like object relationship mismatch or something like that. So how Java approached this, like Java libraries in the object-oriented, is that when you access person and then try to call its orders, you see an interface list, but actually what you have in the middle is a proxy dynamically generated. And this proxy, the moment that you touch it, will go to the database and fetch the data. So you have like some kind of side effect that is like really, really hard to see and really hard to control. And this had some kind of like really nasty results, like if you were creating some kind of application that was like a classical three layers, like UI, where you generate the HTML, from some kind of template, you have like services and database, right? So if you would move these orders from your service level to the UI level, the DB connection would be closed, and programmers were like super surprised that you get an exception that database was already closed, so I cannot give you the orders, which was really nasty. And what happened, like there's a cottage industry of experts who tell you how to actually overcome the problems that you might not have in the first place. So how Java, like what Scala brought to the table at some point? So Scala just said like just use data, right? We can just have like pure data without some kind of like proxies and stuff like that. So Scala had case classes. You for sure know all of this, right? So we have some kind of address, person, We can create it, like we can print line it, we can like serialize it, serve it over the network, like have a function that will store it in the database, everything. So I would say that you could still do the same like unconventional way as you did in Java, but there was some kind of cultural shift, I would say, that people didn't do. Like a question to you, probably Scala programs, would you put a database connection into case class here? Probably not, right? Because this is just something that is like considered bad Scala code. So exactly, this cultural change affected also Java at one point. So this is like the first thing that we'll be looking into. So Java records. So let's maybe start with what this is. This GEP 395. So GEP is Java Enhancement Process. So there's like so basically people who are Java architects write documentation, the documents about how they want to change the Java language. So they'll, of course, like review it, like do some kind of iteration, and then this thing is introduced into the Java. And this records was introduced with JDK 16, if I remember correctly. Yes, and this is basically a copy-paste of what we have with case classes. So we have record keyword now in Java, basically like name of the type and all data that it contains, right? You have another record, like you can put a record into a record, you can print line it, it has a nice two-string thingy. So what this record is actually underneath. So underneath you would get like equals, hash code, getters for all of those. Those would be like private final fields. And like this record thing cannot be extended. Like you cannot like do like inherit from it. So it's even, I would say, better than in Scala because you can inherit from case class, which is probably not a greatest idea. But they can implement some kind of interfaces. And what else? Maybe just a technicality that all records inherit already from Java lang record. This is like similar if you know that enums are also designed this way. Okay, so how can we use those records, some kind of like details? So basically those records have a notion of, this is called canonical constructor and non-canonical constructors. So you see like the whole state of the record is contained here, but you can have a constructor that will somehow alter it. Here we have an example when we have a function that gets the greatest common divisor between two ints. So after we pass the num and denom of the rational number, we use this GCD to like lower both numbers. So when we would create new rational 105 as an argument, actually underneath it would be like altered. So this is like still safe. You can still use hash code. Like this is all fine.
What are those two last lines in the constructor?
You mean this?
These operators.
This is like a division and equals, just glyphs. That's why it looks so funny. It's like plus equals, right? But this is like division. Okay. Other thing that you can do in constructors, also something that we like to have in Scala, right? We like to have valid domains, right? So if it's constructed, then it's like a proper thing. So for example, we can validate if, for example, range, the lower side of range is actually bigger than the higher. I mean, you'll probably be frowning upon throwing of exception, but this is still Java, so this is how this would be probably done in Java. But at least you're sure that record, if it was constructed, it is a valid range. So that I think is a good thing. So now in Java, it's easier to actually create things like, I don't know, person ID and not use strings or integers. So something that we really like to have in Scala, right? More types. Now, somebody might ask, what about tuples? Because like from records to tuples, it is very close, right? So we have tuples in Scala, and like you can use them at like any point in the source code. So the Java architects said that they won't introduce tuples. Why? And this is sometimes like interesting to read those documents actually, because there is also some kind of rationale behind why we didn't do something or why we did it this or that way. So they said that Java is focusing on being a language where names are important. So tuples are actually like ordered data but not named, right? So they said we want names. So to somehow ease this problem, they allowed to create local records inside the method. So here is like an example that we want to find the top merchants. So we have a list of merchants and a month that will be calculating the sales. So we create a local record, merchant sales, which holds the merchant and the sales. And here we'll have like a pretty standard like stream operator, like mapping merchant to this merchant sales record, sorting it with this compare. The order is changed because we want to have descending ordering, map it back to a merchant, and collect how this kind of limited number of options would be modeled in Java 20 years ago. So like Java programmers love to create abstract things, and they really hard try to accommodate for future use cases that might never come. So I guess how this could be like modeled. So this is like a example from my, let's call it my day job. So what we're doing is we're like trying to segment people into different categories. So how this would be modeled? So we would have some kind of abstract segment on top. And we want to have like different subtypes, for example, keyword segment. So this is like segmenting people using keywords, or category segment, segmenting people using categories. And we have some kind of external service that can use this data, right? And it will be able to work with all the types. So we have a segment creation service, which basically takes an abstract segment, creates segment, and notifies some kind of service, whatever that might be. This is not important here, right? So basically, if you want to have some kind of like free way in how you do things, you need to, for example, you might want to store the abstract segment in a database, but you might want to create it over HTTP call with REST. So probably how this would work is you would have like this kind of this thing created, like this, for example, keyword segment. It would take an HTTP client, a Java connection, and some kind of configuration, maybe even in runtime, that which would like switch between the two data sources. And why this is bad? I mean, one thing that goes out of the window is separation of concerns, right? Because like we have mixed everything, data types with side effects, with HTTP, with SQL. And well, in theory, this is good, right? You can add more of those types. Like, for example, you could have, I don't know, some kind of custom segment, whatever. But again, this would like leak, right? You see, this says that I throw IO exception. But like from your experience, there's a difference how you work with Kafka, how you work with HTTP, right? And how you work with, for example, database. So probably you don't want this to be hidden from you. And of course, what we do in Scala is we just use sealed traits, right? Sorry for the cutoff, but I guess you know this is like a sealed trait segment, and all the case classes, which are all the possibilities that we can have, they all extend segment. So something that I'm pretty sure you're well aware of and you're using in your day-to-day job. So pure data, no side effects, and then you can have a function that will work on all of this data, right? And again, Java follows suit here. So we have JP 409, which is about sealed classes. It was introduced in JDK 17. So this looks very similar to what we have in Scala. So we have sealed interface, or a sealed class. I will show sealed class in a second. And we have like a list of permits. So there is a list of all the subtypes that can actually be this segment. So in Scala, right, we need to like define all of them in the same file, right, if we want to do this. In Java, it's a bit different. It might be in the same package, or there's something like Java modules, which you might have heard of, but nobody uses it. It was introduced in Java 9. This is not important. Anyway, this is the same way of modeling things as we've been doing in Scala for the past quite a few years, right? So basically now with this, and with records, we have basic algebraic data types, right? Okay. And here's another example. So we have, because this is not only about interfaces, but also like you can have also sealed classes, not only sealed interfaces. So this is a more like rich example because you have like a sealed class shape and all the sub types, but there is also one type which is not really final. It's also sealed, you see? So there's a type that can be also sealed and has further down other options, right?
Is this shape also abstract?
It can be. I mean, like how Java says you can have abstract things, then you can have like abstract children, but like you cannot leave it open. And there's a new also, and you need to mark it that it can be still somehow inherited. There's a new keyword non-sealed. So we have like a strange shape which is non-sealed. So how this helps? So basically it helps with the like pattern matching being like, we're running into future, I will be talking about pattern matching in a second, but the thing is that you can pattern match on all those shapes and you're sure that you're covering all the use cases, right? Maybe you won't have like a pattern match for all the children of the non-sealed class, but still the pattern match will be like full, right? Okay.
So the children is be either final, sealed, or non-sealed?
Yes.
So must be explicit.
Yes, must be explicitly defined. Cannot be just a class, which would be like randomly opened. Okay, so that was about the data modeling. That will go to the algorithm modeling part. So what we want to achieve with the algorithm modeling. So we want to add new algorithms to our data types, but without altering the data type itself, right? So you want to have like some kind of data type here, and you want to have like additional multiple algorithms working on this data type. And you want to keep it type safe. So how could you do this? So basically the easiest way in Java in the past was to use instance of. So basically let's say that we have interface element. So this is like a trait, right? And we have like records, element A and element B, which both implements element. So like a record is like a case class in Scala land. Then we have like an external algorithm which processes the element. And what we do in each of the if branches, we check with the instance of which of the elements are we processing now. So some Java code did this like this years ago. There's like, I don't know how many of you actually wrote Java, but there is also like, I sneaked another GEP here. Basically in like older Java instance of could only have type here. Now it can only have like a name. So this is not only checking for the type, it also casts it. So you don't need to do a cast here. So anyway, like some kind of small addition that might be not visible. Okay, so why is this bad, right? The bad thing about this is like this list can be super long, and of course the worst thing is else, right? So like you add a new type and you don't know that the algorithm won't work with your type. So how Java worked with this? So how many of you maybe used a visitor pattern? I'm just like curious how many people actually still use this thing used in your life. So visitor pattern also sometimes called like a double dispatch. So the idea was that you have the same hierarchy of element on the top, element A, element B, and you have some kind of visitor, and it will be like the concrete implementation of the algorithm. So what you need to do is you need to add this method accept, which takes the visitor, and all the implementations actually pass themselves to the visitor. How this works? You know that like if you like in Java in JVM, I mean, if you call a method, the first argument of this method is actually always this, right? You probably know this. You do like object dot function, but it's actually being rewritten as this function, and first argument is this. So this works that when you call a visitor, it first calls on the visitor level and then on the element level. So what can you have? So for example, you can have a concrete visitor that does print lining on the element. And how you use it, you just go through the list and for each and pass the visitor to all the things here. So one nice thing about this is quite fast. So I know there are some libraries that actually moved to this version of dispatching. For example, I know Cirque, the famous JSON library, is using this. At least it used it underneath because it was a lot faster to process all the JSON types this way than actually to do a proper pattern matching. And yeah, about pattern matching. So in Scala, what we would do, we would have just like a proper pattern match. Like we would do like element match, case element A, element B. This would be exhaustive, right? And we're all good. And again, Java follows suit. So in JDK 21, so again it's closed, we have like the same possibility. So we can have like the sealed interface that permits all the elements. We have records here, so like case classes. And you have a switch which you can actually do a case pattern match on all of those. So there is like an implementation of the algorithm isTruThy. So if the element is actually like a falsy or truthy, so it returns true or false on the value. So you can have like implementation. And the Java compiler will actually check if this is exhaustive. So this is a good thing, the same that happens in Scala. You remember this example with the shapes? So this pattern match, it's also can be a bit like richer, because like historically switch in Java was only for statements, so you would need to do a break at some point, you would jump out. Now switch in Java can actually return a value. So we switch on a random shape and like we return some kind of random value. So instead of semicolon here, we use arrow and it will return. And you have a possibility to actually do some kind of side effecting, like here for shape, circle, we're print lining something. But then there was a problem how to actually say that we want to return something. Like in Scala, it's implicitly that the last thing in the scope is returned, right? In Java, there is no such thing because it's statement-based. So there's a new keyword called yield. So basically, why we couldn't use return here? Because like return would jump out of the whole function, not only from the switch. People are laughing. I mean, like Java architects did their best. Come on, guys. Okay, did I check? Oh, sorry. Another nice thing that's also like, I think, taken from Scala is this guards. So this part. When you're matching on an element, you can actually use a word when, and then check if the value like is actually like, so you can check some kind of predicate over here, right? And then the proper case will be executed. Yeah, and as I said, the nice thing is that the switch statement is being checked. So this is like screenshot from IntelliJ. So IntelliJ will actually tell you if not all branches were covered, which is nice. But it's like, it's not super smart, but it's better than nothing, let's say like this. It's okay. Also, it's, like I said, it's not super smart, but it has its like kind of like blisses sometimes. Like for example, here we have a generic interface, and this generic interface permits A and B. A is also generic, but A says that it's implementing E on string, B is implementing, again, on generic value. So this switch actually knows that the first case actually checks all the possible values, right? Because A case is not possible, because basically like we're switching on an integer of E, right? So it is sometimes smart, sometimes not, but as I said, better than nothing, I would say. Okay, another thing, like connected to the previous one, are called so-called record patterns, so also something that we know from Scala. So let's say we have this kind of hierarchy, so we have a drawable, which has like a point to D and a colored point. So point to D is of course like X and W, and then you have colored point, which takes point to D, so it takes as this record as the first, and a color, right? And color is also a record. So you can actually deconstruct those records. So we're doing a switch here, and on point to D, you say that deconstruct it, so you have both of the fields here, and here you have like you can go deep inside and deconstruct that the first argument was actually a point to D and go to its values. And here you have colors, you can have those guards and stuff like that. So it's getting like really, really close to what we have in Scala, right? So the modeling part is really close right now. Okay, so like something that was super unexpected for me, like string concatenation and string processing in Java. I wouldn't expect that this would be probably the most exciting thing that they did, but it is. But like, stay with me. So how would you do string concatenation in Java like 20 years ago? So you would use probably pluses. So this is, you would have like an SQL query that you would need to connect with pluses on each of the end of the line, which was really not very comfortable to write. I mean, I did it and it's like super annoying. And if you would want to have some kind of like parameters here, disaster. So obviously Scala brought us the nice triple quotes and the strip margin, which is like automatically filled in by IntelliJ and everything. So this is like super nice and works perfectly fine. And again, Java didn't reinvent the wheel. So since JDK 16, we have so-called text blocks. So again, we have triple quotes here. And yeah, you can basically write any kind of string here. You might be asking, what about the indentation, right? If I print out this string, because like if you put this variable into some kind of code, like it will be in a function or a class, it will be indented, right? So how does it know how much indentation it should like cut off? So actually underneath, what it does, there's a strip indent function, which is exposed as an API, so we can call it yourself. But what it does, it actually splits each line into a list and tries to strip the beginning until it finds the first non-blank character. So it knows how much it needs to cut off from here, and it does the same cutoffs here, 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 and then takes this list without this prefix cutoff and reconstructs this whole thing. So if you print line this, it will like print line in a nice way.
Can you write something in the first line with the triple quotes?
Yeah, that's actually like a homework. I said how the algorithm works. Now think how that would change if you would take this to the first line, and how that would change if you would actually do the triple quotes here. Does it change someone? So a homework for you. Okay. Another JP, 430 string templates. So this is something that we obviously also have in Scala. So string interpolation, I think we call it. So the syntax is really nasty, I would say. So how you use it? So you prefix the triple quote with a str dot, and then you can actually put your variables here. You need to do a slash or backslash, never knows, backslash, and curly braces, and this will be obviously like extrapolated. The interesting part is that they went a bit further, so this is not only about string interpolation. So how this works underneath, there is something called string template, which is like a raw string, and you can have different interpolators for different use cases. For example, you can have an FMT interpolator which understands how to format floats. For example, how many things after the dot you should like keep. So you need to take this raw template and like process this template to actually get the like thing that you want. And they went even further because you can actually build kind of interesting thing with this. So one example is JSON building. So you can have a string template processor which takes this string template and returns an JSON object from the interpolated thingy. So you can have JSON dot triple quotes, and you can build a JSON thing And you can also try to do some kind of validation if this is like actually valid JSON. Also, like another idea, this is like copied from this document. So you can have something like a query builder, which actually allows you to build your SQL query. There's like code how this works. It goes through the SQL query and like safely exchanges your parameters to question marks. And how this works, you create this query builder, give it a connection to the database, and then this DB object can be used as a prefix. So you have here DB dot select, and this is like all good to actually execute as a query. So I'm wondering if they will like actually somehow extend this API, because it seems that this has a lot of potential. Okay. Other nice additions. So Java gained shell. So basically, like something like we had in Scala since forever, I think. The interesting part is that like it works really well. I mean, it's like easy to use. It can like do everything you would expect it, like to, I don't know, give you the list of methods on the object and stuff like that. Like this is nothing special, but I wanted to show you something because it was really funny what I discovered at some point. So let's say you create a int square function in this shell. The shell tracks the list of things that you entered here, and you can edit it, right? And when you call edit square, it actually launches a GUI notepad in Swing where you can actually edit this code, which is like super, I would say, not expected from me. You can edit the code here, call accept, and this square, after being changed from, should be like 2x's multiplied, I did 3, and it actually changed to 8. So just like an interesting thing. Okay, so other nice additions. Also in JDK 21 in preview, so not yet stable, but are there. So unnamed parameters and variables, like as you would expect in Scala, right? The underline. So if you don't need a name, you don't need the return value, you don't care about the exception reference, like you don't care about the parameter and function, you can use it. So very similar to Scala. Also unnamed classes and instances and main instances. So something that you can now try to do scripting in Java if you're really like brave. So basically you can create a hello file which will invoke Java. You need to pass like which source you're using. I had to use this enable preview because this is in preview, so it's not like available. You have a main method without like a class that is like enclosing this main method, and you can call it. I don't think there's an option to actually add some kind of dependencies from Maven Central, so I guess Scala CLI is safe, I think. And yeah, and the same goes with like if you have like a normal thing, you don't need to do a scripting. You can call Java like it was a scripting language by just calling Java. So this is like Java, foo Java, and it prints hello from foo. So it looks like Python, right? You would do Python main PI and it will just work. Okay, so that was all that I wanted to share with you. I don't know how we stand on time. Did I go over? Maybe I did. So the good question is, what's the value in Scala? I mean, Scala 2, like, let's keep Scala 3 out of the question. Like, Łukasz after me will show the niceties in Scala 3. But does it make sense? Because like Scala has its own set of problems, like binary compatibility, things like that. But there is still, like, I had a fortune or unfortunate to write something in Java lately. So there is still a problem in culture. So although you have all of those nice things available, people don't use them as much as in Scala. So there's some kind of mind shift that needs to happen. Obviously, Scala still has immutable collections, which are super useful for things like records, right? But other than that, if you really need to write something in Java, you have the tools to do it like a bit nicer than the boomer Java programmer had it years ago. So that's it. Thank you for listening. I hope you enjoyed it. Maybe questions? Yes, you need to like.
Cool. I addressed that.
You need to do try around. This is Java still. I mean, this is like the example, right? You have the whole thing, the process method that processes the string template. This is just code in runtime. This is not compiled, for sure. Yeah, thank you.
Okay, thank you, Tomasz. I guess it's time for a break. I still have a lot of tokens to exchange the bar for drinks, so I'm gonna get some. We'll try to restart at 8, but no. I don't want to get into human interactions if there are any, so we'll see. I guess I can introduce you officially. Thank you for coming. You're our special, Łukasz, our special guest from Kraków. And recently is the person to gather all complaints about Scala and fix them in no time. So if you want to complain, I guess you can show tomatoes or maybe talk with Łukasz later. Thank you very much for coming and good luck with the presentation.
Hello, can you hear me in the end?
Yes.
Awesome. Cool. So my talk, I won't be introducing myself, he did that already. I'm also a bit sick, so if I start, coughing nervously, please ignore that. He will edit that and nobody will know the better. Okay, so my talk today is called The Good, the Magical and the Insane. And this talk is mostly inspired by our work at BSOM's API, but not only. And it's a selection of stuff that my friends from the compiler team have come up with. So the slide is obligatory. You probably know me already. If not, I'm Scala developer advocate, like Łukasz said. And if you have any problems with Scala, if you have any requests, complaints, come to me, tell me. I'm available everywhere. You can reach me on basically any channel that is available anywhere. Either way, this talk will be about new design patterns for people that build libraries. But if you are a user, you will come in contact with those patterns, especially if you are going to adopt BSOM. So we are building a lot of stuff using Scala 3, and we have a selection also of Scala wizards that we keep closed in Ivory Basement, where they come up with those weird ideas and then implement them in compiler, because why not? So I've gathered some of their ideas and rated them. Some of them are a bit interesting, and that's the last segment, the insane part. So I've decided to put those ideas onto 2 axes, 4 extremes. So we have neat stuff. That's stuff that is very useful, very nice, has virtually no problems in developer experience area. So the opposite extreme is cursed, things that are very weird, that don't really look like they should compile, but they do. They might be useful, but maybe not very much. They definitely have high what the fuck per minute factor. So the overall DX is not very good. We also have, in the vein of the proof is trivial and is left as an exercise for the reader. We have trivial stuff. So stuff that doesn't really, if you know Scala, it's probably very easy to understand, to grok. It doesn't abuse language features, doesn't probably cause weird errors in intersections of those features. And we also have the opposite. We have the magical stuff, the stuff that uses the bowels of the language, that is quite contrived and has some, well, gnarly parts. Okay, so here's a visual chart. I hope it's visible for everyone. This is the place where we will put our selection of APIs. And I have some examples to let you understand how I think about those, about the scaling of those APIs. So to start, option.get is a trivial API, but unfortunately it's quite cursed. It throws. It doesn't require any special understanding to grok it, so that's why it's trivial. But on the other hand, developer experience leaves quite a lot to wish for. On the other hand, non-empty list is also trivial. The implementation is very, very simple. So it's basically a case class with head and a list that represents the tail. So nothing very interesting here. But in fact, it turns to be very useful, and it helps avoiding many different mistakes. On the magical side, we have a type class that is in the standard library, numeric T, and the APIs that use it. So .max and .min on the collections. It's only available for collections that contain things that numeric is implemented for. So it's a bit magical. You kind of have to understand how type classes work, how implicits work. But on the other hand, this API proves to be very useful. It's very helpful. When you get it, it's very, very nice to use. And also we have something that is very magical, and the usefulness is debatable. It works, can be used, but also proves to give you a lot of headaches. So for instance, magnet pattern, as it was used in ArcHTTP, was a source of problems for newcomers for a long time because it used nested implicits. So just to quickly showcase what the magnet pattern is, if you are not familiar with it, it uses an implicit to disambiguate between overloaded methods, because erasure would otherwise cause a problem. So in this case, we have two instances for different lists excuse me, that pull different implementations of the magnet, and that allows us to do this, basically. Now, marshallers for ArcHTTP also pull implicits to encode stuff, and that means that you have two layers of implicits. Errors are not very nice, so that's why this is sort of cursed, sort of problematic, and not very nice. Okay, so to put that onto our compass of usability, the neat and trivial stuff, non-empty list, trivial and a bit cursed, option.get, magical magnet pattern, also cursed, and neat, but a bit magical, numeric T. Okay, so let's start with the selection. I'm going to start with the good stuff. Okay, so horrors are at the end. Let's talk about stuff that isn't really new, but it's very easy to use right now. Custom refine times. When you are in your code base, in Scala 2, you usually wouldn't want to implement new types on your own, wouldn't like to get into those things because they weren't really user-facing APIs. They were a bit of a hack on the type system. But now those things are usable. So if you need to constrain values that users of your Scala API can provide, you can leverage this. Is this readable? Not really. Oh my. What can we do about this? It seems not much. Well, let me maybe go through what we are doing here. So we declare an opaque type that is a subtype of a string. We could drop this subtyping relationship, and that would mean that this type wouldn't have any methods that string has. That is useful, but and it also plugs a hole, because if you do this, if you declare an opaque type as a constraint string, as a subtype of string, it means that any method that is declared on string will return a string. So it will leave your safe enclosure. But most of the time you want to do this to verify some properties on creation of the type. So it might be worth to just use the subtyping relationship in the definition, and then, well, you just leave the safe type and you have a string. Either way, if you declare this type as a subtype of string, you can use your opaque type in any place that declares that it takes a string. That's very useful. Now, what we do here is we create sort of macro-ish compile time inline definition, the function that verifies the string in compile time. This obviously only works with literals, so you can't do this with a value that is only known in runtime. You have to, go through usual runtime validation and then probably use some effect like either or try or whatever to handle the error case. But if your API is to be used by your users using literals in the code, you can do this. And this allows you to catch multiple conditions in compile time. And it's quite easy with the package scala.compiletime. You can just put additional quite trivial validations. Like in this case, we only verify using a regex that the string starts with some prefix. And we can crash the compilation if the string doesn't fulfill this requirement. We can also define an implicit conversion. So this allows for some very nice stuff. For instance, in this case, if you can see this, if you can't, I'm very sorry. We can assign a string to a place that is typed with our constraint str type, and the compiler will use this inline conversion to convert it to the type that we want, and if there are any errors, it will crash the compilation in this place. So very nifty. This can be taken much further, and while this version, which only uses Scala compile package, is a bit magical, but not very much. It isn't really the true metaprogramming. It's simplified. It's usable by mortals, basically. We can use metaprogramming, full metaprogramming API in this, and do really, really gnarly stuff with that, and provide validations that go through whole trees of your code base. But that would push this technique to the magical side a lot. Okay, so the next one. Are you familiar with Postle's law? Not really. I think you are definitely familiar with the general idea. So the idea is that you should be liberal in what you accept, but conservative in what you return. And in case of API design, you have situations where you would be fine with multiple things that user can provide just to improve the experience of using your API. But in the end, you only care about the common denominator, the thing that you will get in the end. So for instance, if your API expects an I/O of something, you could take A, you could take I/O of A, and that's exactly what we're going to do. Sorry. So in this case, we, again, leverage opaque types. We declare an opaque type called optional. And this time, we use something more interesting. We use unions, but we also declare that the optional type, how this relationship would be called? Well, it's a this type is the super type of optional. So, or am I wrong? I might be wrong. Anyway, let's continue. We declare that this optional type would be an alias for A or, so union, of option of A. And that allows us with this nice extension. This actually is only usable by us. It should be only usable by us, by library implementer. This extension allows us to then handle any value that comes with within this optional type. So when you design your API, this will be actually this my API method that takes an argument that is optional of int. And what you can do, the interesting bit is, you can, for instance, provide a default that is none. So in this case, when you use this, when your user uses your API, the user can provide a row int, and it works just fine. User can provide an option of int, and it works just fine. User can provide no argument at all, and it also works fine. And the user can also provide a none. So we accept multiple types. This can be taken much further. It's only actually limited by what you can check in runtime. If you go overboard, because as you can see, there are some unsafe operations going on here, they can be improved with new features that Scala 3 has, which are called type tests. But I didn't go into type tests here because I wanted to simplify stuff. You could have this type check to some degree, but if you do some very JavaScript-esque things like multiple types being possible, multiple generic types being usable in the same place, it can get messy. So it's limited to stuff that you can verify in runtime. But if you are working with stuff like, for instance, I/O or option, your API is typed that it can only take an option or A, right? Okay, so that's fine. Let's go and rank it. So opaque inputs are actually very useful, in my opinion. I think they should become a staple in Scala 3. They help a lot with APIs that should be flexible for the user, and in the end, you only gather stuff in your own format on your side, on the side of the library. So neat and only a bit magical. It's not very tricky. It's just union types. Okay, next one, context proxies. The name is evolving for this pattern. The author is Michał Pałka from the compiler team. And I used to call this magnet functions, but it's actually not really similar to magnet pattern. So we have discussed that we should change this name to just context proxies. Either way, this is a bit more esoteric. There are some use cases where you can see this being useful. But it works in a bit constrained scenarios where your APIs have multiple shapes. There are multiple different shapes, and you would like to make things more usable for your user by using unified interface in places where users would have to provide different data types, for instance. So here's an example. I think I left this a bit by mistake, sorry. What is really important here is that we have two different types for options. So we have options for A, options for B. One takes only an int, and the second one takes a string. And the important bit is the variant thing. So we have a sealed trait called variant, and it has a member type constructor and a value constructor of this type. Why? Because we can declare traits that extend this variant, so members of this sealed trait, and parameterize them using the apply, actually. So we are using the companion object as the type for the constructor, and then assign the companion object for the constructor. Why? Because it has an apply method, so it can be just used as a function. We then just create objects. That's only done for nice API. And the most important bit here is the opts function. So opts function is going to be our proxy. Opts function uses the variant. And what it does, it only returns the constructor type and the value. So how does it actually look in API design? We have two versions of this API that are designed the usual way. So you can see that those APIs differ a bit. And one takes a string as the first parameter, second takes integer as the first parameter, and they take their respectable options as the second argument. So we would like to streamline that. That, you know, might seem stupid in this case, but if you have hundreds of such methods, it suddenly, you know, makes sense that things are unified. We can rewrite that to the smart version that uses this pattern, and then we use options as a context function. Context functions are a new feature in Scala 3, and I have no idea why this works, by the way, but it works, and that's absolutely awesome. So we declare that for the smart A API, the options is a context function that provides the variant A, and then it expects that whatever function will be done here, it will return options for A, but we control this. Sorry, we control this function because we have declared the opt here. The only possible instance that can be used is this one. That's also controlled by the sealed trait. So what happens here is that when you use this, actually, the original API requires that user imports the options for A, options for B, then create an instance, pass it as the parameter. Okay, that's usable in this scope. It gets out of hand if you have multiple APIs like that. But what you can do here, you can then use the proxy to, well, pull like a magnet the correct constructor. So the context function will somehow, I have no idea how it works, sorry, questions to the compiler team. The function here will, will pull the constructor, and this application here, oh shit, oh no. Wrong button. This application of the function here is actually the application of the apply. So as you might recall from the previous slide, this was the apply here for int, and we have for b the apply for with single argument of b of string. And that's exactly what is happening here. You have apply of int and apply of string. So we have cut down the imports that are necessary. You don't need that import. It will be resolved by the compiler itself. And also, the API is unified. Nobody has to know anything about this. This actually was designed first for Iskra. And if you are familiar with Iskra, you might know the dollar operator. It does basically the same thing, but it does a lot more magic with refined types to make, you know, the row types for Spark pipelines work. Okay, so the use case is a bit niche. You have to have those APIs that actually have those multiple arguments that user would then have to import, remember about them. So it's not that useful. So it's a bit lower on the need cursed axis. But on the other hand, it's not very magical, and it seems useful enough. If you have a use case that needs this, it's a good way to do this. Next one. Okay, this one actually is kind of neat. It was doable with Scala 2, but now it's much easier to use. So it was a common practice for Scala developers to wrap Java APIs. And usually that meant that you just allocated a class, wrapped the delegate from Java world, designed some APIs, and then you would just use this wrapped class, this wrapper class, instead of the Java class. That meant obviously that you had to allocate this class, and if you have more sensitive, more performance sensitive application, that isn't very good, especially for classes that get to be created in hundreds or thousands of instances. So what you can do, you can use opaque types and just wrap a Java type, create extensions that do the same thing as, they have the same shape as the API that you are using before in Java, but they are safe. So create new file, throws. And we can just wrap this here, return an API that returns you an either of an exception or a Boolean. You can also improve those APIs with refined type libraries. Like, for instance, in this case, we are using iron library that allows us to declare that long is positive. So the set last modified method throws if you pass an integer, or sorry, long that is not positive. It has to be a positive. So we can improve the API. We can just guarantee that this value will never be not a positive value. And therefore, this API will never throw. So we just use it as it is. And this gives us APIs that work like this. So set last modified on the file will, in this case, give us a compile error for 0. Create new file will return an either on which you can pattern match. So definitely an improvement in terms of usability, and definitely an improvement on performance side. So for instance, files get to be created in hundreds. In this case, you don't have to pay for additional allocation at all. Okay, so it's actually quite simple. It doesn't require any additional magic. We are just aliasing the type. The opaque type, if it doesn't have the subtype relationship, doesn't inherit any methods. And compiler will know that those extension methods are not calls of the methods. They are separate functions. So it will call the correct functions that you have declared. Because the type is opaque. Okay, so not very complex, more on the trivial side, quite neat. Let's go to the gnarly stuff a bit. Those are the magical APIs, things that require some understanding of how more arcane features of Scala work. Oh, that's the feature that Tomasz, who was speaking before me, mentioned in Java. So you need to allow your users to interpolate weird stuff, like, for instance, JSONs. And you could do this in Java, like Tomasz has shown. But the problem is if somebody enters JSON string that isn't correct, and it's not in the top level of your application, and it will be only executed, let's say, on HTTP request path, it will crash in runtime. So it would be good, given that we know that this is a string literal, right? We are interpolating it. It would be quite good to actually make it type safe, because why not? So jump to VS Code. This actually gets a bit involved. All of the examples that I'm showing will be available as a gist on GitHub. Everything compiles, by the way. So you can use it, you can play with it, you can modify it. This is the implementation of the macro interpolator called JSON. And the implementation, I'm not going to go into details of that, mostly because I would basically compromise myself. I am learning metaprogramming API. It's not as bad as it was in Scala 2, but there are still things that I'm not very sure about. Either way, what we are doing here in this API, we are making sure that any string that is interpolated is a valid string according to Kirky library. So we are importing Kirky, and we are returning from this macro a JSON object, but it is safe. It has to be verified in compile time that the string we are interpolating is a valid string. So if you are familiar with API of string interpolations, you basically have to implement a combination of sequence of strings, so the fragments between interpolated values, and a sequence of interpolated values. Given that this is Scala and we have macros, we can check the types. So what I'm doing here, I'm actually checking that stuff that is interpolated only makes sense in a JSON. So we can only interpolate strings, ints, longs, floats, doubles, booleans, and other JSONs, because you can nest JSONs. But to verify those values, interpolated values might be known only in runtime. They don't have to be literals. So what we are doing here, we are substituting every single type that will be interpolated by a default value that will have the same shape in actual runtime. It has to have the same shape. So we are replacing all the values excuse me, with the defaults. If there is anything other that doesn't fit, we can then nicely report that to the user with a nice information that this value cannot be interpolated. If you want to do something like that, you have to use one of the values that we accept. And what we do then, we interleave stuff. We interleave stuff, and then we parse it in macro with Kirky's parser. If the parsing fails, we report it to the user. So the JSON that was passed is not correct. If it's correct, on the other hand, we have to, sorry for that, I ran out of time to fix this. It actually works with another JSON library, but I've ripped that out from BSOM. So we then take those actual values, that trees of them, or rather expressions of them, because that's happening in compile time in a macro. We take those parts, those expressions, and we again do the same thing. We interleave that in the quotation here. So this will be the code that macro outputs. We fold that string by basically getting all the things one by one concatenated to the original empty string. And we output also the function that will parse this, because we can't just put it all together as some of those values are dynamic. We have to do the whole dance. Well, again, we know that the value will be correct in compile time, but we still have to output the whole parsing thing, mostly because moving stuff between stages would be quite complex. It could be done. I think it can be done. I'm just not Michał Pałka. So other than that, in the end, we get an expression of the JSON expression containing all the code that will yield the JSON to the user. And the actual code here, does it work? Yeah. So this is the API that user will face. So we have some values to interpolate. This will be probably better. So we have an integer. We have a JSON object containing field C with a JSON string hello. And then we interpolate. So this is just a usual string with an interpolation of JSON. It returns JSON, prints JSON, all is fine. Now we interpolate this integer here. All is fine. Again, it's all compile time checked. And the same thing happens if you do something more complex. So you can interpolate the integer, you can interpolate the JSON. Again, works without any issues. I think I have a case where it fails to compile. I didn't put it there for some reason. Oh no, this won't compile. Yeah, can you see this? Any chances? A bit? Okay. So you can see that this is live compiler, failed to parse JSON, default values inserted at compile time, expected double quote, but got curly brace. Cool. Doesn't compile as we wanted. Okay. Oh my, I'm lost. Okay. Okay, so a bit magical, but you can do a lot of stuff with that. So it's more on the magical side. It's not very trivial, but again, it's something that your users will only use as an API. You have to understand how it works, but on the user side, it's actually quite understandable. It depends on what you do, actually, because you are in control of the compiler errors, and you can provide a lot of useful information, like, for instance, the iron library does, as you have seen before. The validation of the type was provided as a nice, pretty printed string with information what went wrong. So magical but neat, useful. Okay, more magical stuff. Type providers. Are you familiar with F# language? A bit. Okay, one person. So F# has something called type providers, and type providers are a feature that allows code to add new types based on something that happens in metaprogramming part of the language. So I'm going to use interpolation example again, but this time things are going to get more hairy, because in the previous example we only returned a JSON from the interpolation. In this case, we want to return a type that is refined by the macro, that information about what is contained in this type is only available in compile time. So jump to GitHub. There's a, oh my, no, I don't think this is the correct thing. Ah, right. Okay, there's a library by Paweł Marks, the lead of the compiler team in Virtus Lab. And this library implements something quite interesting. So what it does, it might be, actually more sane to go the other way in this case. Do we have time, by the way? Okay. So library itself, dear Mac, why are you doing this to me? Is it going to, yeah, okay. So what it does, it allows you to write GraphQL queries as interpolated strings. And the problem with GraphQL queries is that they declare what is the shape of the response going to be. In most cases, this is done by some kind of code generation. But in Scala, well, we can do this in compile time. And that's exactly what this library does. So in this case, you have a query for GitHub GraphQL. And you have quite a nested query with a lot of subtypes declared here. And then when you use this, what happens is, well, magic. This type here will contain a safe refinement that allows you to access fields that this query can return. Those values are guaranteed to be there because that's how GraphQL queries work. So it has to have this shape. Compiler knows this because it has parsed the string of the GraphQL query. And then the most amazing bit of the stack is that if you are using medals, the compiler is able to fit this information to the IDE. So the actual refined type here is not only, if you remember old dynamic APIs of Scala 2, they weren't really checked. They failed in runtime. This isn't runtime. This is checked in compile time. If you try to access any property that doesn't fit, doesn't match what was in this in this query, compile will fail. So Biały here is accessing some of the information that is available in the response from this query. And as you can see, all of that stuff is type checked. And also in Metal's IDE does support the autocomplete. So you can see what values are there. So this is basically type providers moved to Scala. And I was thinking about showing you how this actually works like in the insights, but I'm a bit afraid, oh no, that doesn't help. I'm a bit afraid that it's quite gnarly and I really don't have much experience with this library. The gist is that you have to use selectables, which are new version of dynamic APIs, but they also are inlines. And end result is that those things are they kind of work like structural types, and they kind of work like dynamic types, but they are based on metaprogramming of Scala 3, and the code is generated by the compiler on demand. So going back to the presentation here, this code is only generated when you actually need this. Compiler generates new bits of the code as your API is being used. In the end, everything is done in compile time. There is no reflection in runtime. And, well, it just works. OK. So it's actually very magical. Has to be on the furthest bits of the magical side. But there are many interesting use cases for things like that. There are many interesting things that you can pull in compile time as information and then chew it in macro and then return back to the user. GraphQL queries are just one example. There are many others. So quite useful. There are, depending on the implementation, there are possibilities of stuff being not very nice to use, but that depends on how good the implementation is. OK. Now this is going to be much more gnarly. We are getting to depths. We are getting into the deep in the Moria. So you have a monadic DSL, and it would be easier for your users if they could access properties and data types that are inside of your monad if they were, just accessing those values as usually. So let's say, as an example, you have a case class that has some fields, and this case class is inside of an option. And wouldn't it be nice if you could just use dot syntax with the name of the property of the case class available on the case class on the option? OK, so sounds a bit weird. Let's see how it works. So general idea is that we are going to use a lot of quotes, a lot of macros to do this. If I can zoom it, yeah, sure. Yeah, so I think we should start probably from the place that starts the whole thing. OK, so we are going to define operators. And this is the less gnarly implementation that uses operators. So the whole thing, as you can see here, can you see this? Are we fine with this? OK, so we declare a method called question mark. And this method returns something, a type that is called, it's a member type of the P value. So what is P value? Because the implementation actually for this method is just P view of this option. This is implemented for options, can be done with anything. So it is an option flat map view provider. And that's a type that gets created by the macro. So there's a lot of interesting logic here. but as you can see, it uses transparent inlines. It uses selectable, and it basically does reflection calls in compile time to check whether those properties are on the type that is inside of the option. If they are, that's type checked in compile time. If they are, you can then use the syntax to access those values almost directly. Going back to the slides. So let's assume that this is our class. We have a value that the value of this value is sum of ABC. We have some methods that also return sums, so options basically. And we then use our API. So we have a value opt, which is an option of foo. And then this will be probably useful now. We can call question mark, and that is equivalent to a map. I haven't shown you the single question mark operator, but it's basically equivalent to map. It's a provider of views for map instead of flat map. So based on that, you can just access the value here. This is all type checked. It's all safe in type safety area, and it works with metals. I'm not sure whether it works with IDEA. It might with the extension that Eagle is working on, but I don't think he published that yet. Anyway, you can see that, well, mapping on options gets us double layers of options. So I get a sum of ABC. But if we use the double question mark operator, we can access this value, and it's just flattened. And we get sum of ABC. The same happens with other methods. So if we apply a single question mark, we get a nested option. If we apply double question mark, we get flattened one. Just as you would write code that calls opt.map, and then the lambda accesses the property, or opt.flatmap, and lambda accesses the property. Okay. So this is actually very magical. Again, maybe a bit less than type providers, but it's very magical. And it's also a bit cursed because there aren't many use cases that I can think of where this API makes sense. It actually makes sense in Bison, but the funny bit is that we didn't use this implementation. We didn't use macros to do this because we have code generation for that, and we are just generating extension methods to do this. And the feature itself is basically taken from other SDKs of Pulumi, where as Pulumi uses monadic API in any language, it's quite useful for users to have this direct syntax, as it's inside of a whole DSL, so it doesn't stand out. If we were to do this with I/O, for instance, it can be done with I/O. It's a bit magical, a bit too much for my taste. But there is also a complication, an improvement, as Michał would say, because this can be also used with implicit conversions. And if you do this with implicit conversions, you don't have an operator. You don't have to call dot question mark. You can just call properties on option, and it works because it all gets inline there, and the whole operation ends up being just equivalent to map or flat map with a lambda accessing the property. So that actually makes it a lot more cursed, in my opinion, and very hard to understand. But if you need this for some reason, you can do this. Okay, and now the most insane part. Let me just hydrate a bit. Okay, so we're going into the area where I don't recommend using this code to anyone. It's experimental. It was meant to see what's possible to do. It's not meant to be used. Okay, so fewer syntax. You are probably familiar with fewer braces syntax. It allows to build stuff that is questionable at best. But let's assume that our API, just like API of BSOM, is structured. You have to pass a lot of properties, a lot of configuration as case classes to do stuff. So, for instance, in TypeScript, you would just use objects, and it's all fine. The API is very nice and very easy to use. We were thinking about what we can do in Scala to match that, because object syntax is in JavaScript and TypeScript is very succinct and very elastic. It allows you a lot if you provide proper typing for that, and it's very easy to use. So we went on and tried to experiment what can be done. I am not very sure if I am able to explain how this code actually works. It isn't using macros, so that's the good part. It's just using clever techniques. So the most important bit here is that we have this function called asterisk, and it's using builders. I can't remember if Michał made it immutable, but it's probable that he did. So we have this class foo, and you can see that there are some properties that have to be set. So we then have foo args builder, and those are, as I mentioned, prototypes for BSOM, and therefore they make much sense in general structure of how BSOM APIs work. So the builder has methods that actually allow you to set values. Oh, it's immutable, actually. It's using copy to set things. But we don't want our user to interface with the builder. We also have a bar class, so we also have a builder for that class. And in the end, we are able to write code like this. Please don't do this. So I think it's almost YAML compliant with exception of parentheses. But this is code that compiles. You can compile this code. It also works. Doesn't mean you should ever do this. Okay, but we had more than one prototype. So this is a bit different. And as I mentioned, it's only a prototype. There aren't actual implementations. We just checked that compiler would allow this. I'm not really sure I can explain this, beside the fact that it uses the assignment API that Scala has. It's still used with, for instance, mutable collections. So it leverages that fact and then allows you to set those values using the assignment syntax. So we have some data types that we want to build. We have those builders that are going to pass those values. I think this one is mutable, actually. And in the end, we write code like this. And the most cursed thing, that's definitely one of the most cursed things I have ever seen in Scala. And compiler shouldn't allow this, but you can do this. You can write new, double colon, and then you can just write another property, assign another value here with, again, new, and then just set another values. And for lists, compiler will be able to actually infer that this type has to be this type that you aren't naming anywhere. So you just write new, and then you, again, define the properties. And it just works. Shouldn't, but it works. OK. So fewer syntax is definitely cursed. It's less magical because there's no metaprogramming, at least. But don't ever do this. Thank you. That's all I have. Question?
Okay, I have more of a comment, maybe that's a question, or maybe something to consider. You show the macro-based string interpolators,
Yeah.
which I think are useful, but I also experienced that pushing all these things to compile time makes some of the APIs less extensible. And I'm talking about like in Doobie, there's string interpolator used for constructing SQLs, and you actually are constrained to a couple of types that Doobie knows how to convert to literal or something like that.
Yeah.
And even if you provide like an implicit conversion from one type to the type that Doobie could, like skunk, not Doobie, could use, you can't, because you are getting like a compile error because types doesn't match. And if it would happen in runtime, the implicit conversion would kick in and accept something that is convertible to that type. So I think that people using these types of patterns should somehow allow this like constructs to be extended, at least like accept types that are convertible to what they expect, not only accept the types that are there.
I fully agree. I am a big fan of designing APIs in a way that the head path is very type safe, but there are escape hatches. There should be escape hatches. So, for instance, in Pulumi SDK in Bisum, when we don't really know what the proper shape should be, we allow a JSON, for instance, as the structure that you can pass. And you go off the guardrails, you're in check, but you can just pass a JSON, and if the API will use it, and it's fine with the JSON, with the contents of that, it will work. So definitely, there should be an escape hatch to allow extensibility. Yeah.
Any more questions? Anybody? Okay, so thank you again, Łukasz.
Thanks.
So I have last two announcements. First of all, if you thought that this years and stuff was free, it's not true. You have to fill in the feedback form. That's something new, but we want to make this meetup better, so we would highly appreciate your opinions and suggestions. So please do so. And the other one is I still have like 16 tokens. So if you are after filling in the form, please use them, because otherwise it will go to waste.
There's many feedbacks we need to write down.
Yes.
I think that like around like 16 people in the room, so one feedback for each and one token, and be done. Okay. Anyway, we can stay here for like more networking. You are very invited to do so. Yeah, and I guess see you in March on the pre-party for Scala and on Scala as well. Thank you.
Thank you.